So in this video, I'll be going through a workflow using PixInsight on the deep sky object. The Orion Nebula is one of the easiest DSOs to locate and find with the naked eye or low-level binoculars. However, just because it's easy to see doesn't mean it's easy to photograph and process. To astrophotographers, it's known to be a bright and colourful target. However, the core can easily be overexposed and creating the visual effect of a blown out core. So let's see how we can hopefully handle this in PixInsight. Before I get into PixInsight, I would just like to say I'm still on a learning curve of PixInsight application itself. So any constructive feedback is more than welcome. Please leave a comment below with any advice and ideas. So quick overview of the workflow that we'll be going through today. We'll be stacking our images within PixInsight using the blink process and then the actual stack process itself, or as PixInsight knows it as the weighted batch pre-processing process. And then we'll bring everything together using star alignment and Hdr composition. And then we'll fall into the similar workflow that I've used on my Andromeda Galaxy video, which is rotating the image, cropping. We'll also be using dynamic background extraction. And next we'll be using the color calibration with a photometric process. We'll remove any green hint on the image using Scnr, and then we'll get into noise reduction. And then the final step in this workflow as well is the Hdr Multi-Scale Transform, which what that does is with the image that we'll be working on, it rescues or brings out any details from areas that are often too bright and can't be seen. So this is where we'll be, this is what we'll be using on the core of the object itself. So to start with, the first process we're going to do, which will ultimately get us towards stacking the images, is called blink. So I've got 99 light frames of varying exposure times. We need to make sure that these light frames that we're going to stack are of good quality. And by this, I mean that there's no satellite trails or plane trails or clouds passing through the image. So although I have 99 frames of various exposure times, we need to make sure that the light frames we are going to stack with our calibration frames are of good quality. And by this, I mean there is no satellite or plane trails or clouds passing through the images, which would make any final stacked image be deteriorate. So Blink is a great tool which allows us to group multiple light frames together and quickly play them back sequentially, which is literally blinking from image to image. And this allows our eyes to pick out any changes from one image to the next quite easily. So to start with, we're going to open up all of our light frames. So this is all light frames that I've got of all of the different exposures. And I'm just going to select all of those, click open, and this will load them into the blink. So the images have loaded into blink, and what we're going to do is, because some of them are still quite dark, we're going to do auto stretch all of these images. So the auto stretch doesn't actually change the image. The auto stretch is just a temporary visual adjustment which allows us to see what blink wants us to see a little bit easier. So nothing's actually been saved or changed to the images. So blink's quite easy to use. All we need to do is set a time delay between each frame. So I'm just going to set this at 0.3 seconds. And then by pressing play, blink will start then to go down each image and display each image on the left hand side. We can also use the arrow keys to go up and down if we want to, or we can change the delay to be shorter or quicker as it goes through. So starting from the top again and back to 0.3 and press play. And what we're looking for on this, on the left hand side here, as I said, was any issues such as, plane trails, satellite trails, etc., going through the image, and we're going to remove those images so that we don't stack those issues into our final image. So just looking there straight away on the third frame here, you can see the scope or the mount's been nudged or the wind's caught it. So I'm going to remove that one by highlighting it as orange. And then at the bottom here, which one is it? Sorry, close the selected images. So the selected image is the images that are highlighted in orange. So I'm just going to click that and it removes it out of our list. And then we'll continue to go through again. So therefore, look at image 6. We've got a plane or satellite trail going through. So I'm going to remove that. 7 continues through. 8, it continues through on the left-hand side here. I'm going to remove that. Okay, so let's continue again. So image 25, possibly we'll hit some clouds here, a little bit of an orange glow on the right-hand side. Just going to delete that to be safe. And then we'll continue again. Okay, so I've been through there and removed the bad light images. So what we're going to do is highlight all of the images in this list, and we are going to use the move selected files to a new location. So this way I'm kind of keeping track of where I've been, as in we started with a list of all 99 frames, and then we're moving to a new location of the frames that we want to continue processing with. So within your file explorer or finder, just create a new folder. Just as an example, click on create and then click on open, and this will move all of those images to that new folder for us. And that's about it for Blink. So yeah, loading your files, going through them one by one, stretching them with the histogram for a temporary stretch, moving through them and removing the images which you do not want to be stacked. And then finally, the list of images that we do want to stack, we've moved to a new location. So back to PixInsight, I'm going to close Blink tool as we're now finished with that. And I'm going to load up the weighted batch pre-processing, script. So this is under scripts, not processes. So weighted batch processing script. And this loads our tool up here. So let's start talking about stacking within PixInsight. With this process, we're going to be using lights, which in the case of my DSLR are colored images that have been taken through my telescope. And on top of these lights, we are also going to be using a set of calibration files, which in PixInsight it calls for bias, darks, and flats. So our bias frames, these are exposures at the quickest speed that the camera can take, and taken in complete darkness with the telescope lens cover on. And the ISO setting was also the same as the light frames, which in this case is ISO 400. The bias frame is a read of noise within the camera sensor, and the bias or read noise is removed through the calibration process, so that noise is not in our final image. Next calibration set of files we're using is darks, and these remove the dark current, which is not noise, but it is unwanted signal, and the darks are taken at the same exposure times and ISO settings as my lights. So in this instance, I'm going to have several sets to match the several exposure times of the lights as well. Finally, the flats. The flats generally correct any optical imperfections, whereas the bias and darks correct any noise imperfections. So I'm going to go through this process once for the 180-second exposure lights, but I then need to replicate it a further 4 times, and so to cut out that time, I'm just going to quickly go over or fast forward the video at that time. But I'll go through the first time round, slowly explaining what I'm doing, and then, as I said, it's just wash and repeat for however many exposure sets you have. Okay, so the first thing we're going to do is load our light images. So to do this, we press Add Lights at the bottom. And this takes us, or we need to browse or find our light images at the start with. I'm going to go to our 180 seconds into my lights folder and select all of the images that I want to apply or want to be stacked. So remember, we're going to be doing this 5 times through, once for each exposure time, and to start off, we'll start with our 180s. So let's continue to load the images first, and then we'll get to the specific settings. So I'm going to add our darks, because that's just one step up, it's easy to get to. So there's all our darks at the same ISO setting. Then I'm going to load our flat files. And in the flats, so you can see here, because I took the time to split everything out, it's a little easier and quicker to select all of the different files, and then finally add bias. And there's all my bias files again, the same ISO setting, and load them in. Okay, so the settings that we are interested in, if we go back to the lights tab, because this is a DSLR camera, a one-shot color camera, if we were to stack all of these images, they would come out grey. But by selecting the De Beer option here, this is where PixInsight knows which pattern is being used within each image, and therefore can actually reprocess and bring out the color of the stacked image instead of just a grey output. So you can choose auto, or I know for my particular camera, it's RGGB. And if you're unsure, you can obviously Google it, or when you are importing the light frames into Blink, if you look into the console output, which is on the top left-hand side here of PixInsight, one of the rows actually says what the Beer pattern is. So if you make note of that, you can use it again here. So RGGB is all I'm going to select here. The other thing you need to check is exposure tolerance. So for all, the camera setting was 180 seconds. If you look here, PixInsight has actually picked this up to be slight variations of 180.10 or 0.1, 0.2, 0.3, 0.4 seconds. So it just shows the accuracy of PixInsight when it's reading these files. If you have this number too low, it doesn't like the tolerance of the time difference between the images. So by increasing that, it makes sure that all of these variations in the 180 seconds will be picked up. So I believe this setting is a setting in seconds. So 7 seconds, this should pick up anything between 180 to 187 or down to 173 seconds. So I'll just increase this a little bit just to make sure that all of the lights are picked up here. The other setting we want to look at is integration parameters. So when PixInsight is going through and integrating, it will actually drop some of the images based on your rejection algorithm. So you can look through here, take a read, but generally for what I'm doing at the minute, I just leave this as auto, and it seems to do a good job for myself. Okay, so we can click close on that. Registration details, so don't change anything in there. Just make sure that apply is checked. On the right hand side here, we need to have CFA images checked, and this makes sure that our De Beer pattern is applied. First time round, I'm not going to check use master bias darker flat because we do not have any created yet. However, after this first time round, we will have some master files and we'll use those in the future for the second, third, fourth, fifth iteration to speed things up, and I'll show you how you do that later. Auto detect the best reference frame. I just check that. So you can go through manually and view all your frames if you want to. However, PixInsight or the weighted batch pre-processing script will pick up the best reference frame for you automatically. And the last thing we need to do is the output directory. So where do we want our image to be saved to? And I'm just going to select the root of everywhere that we've been selecting our files from. So again, moving forwards, everything's in the same place, and that copies that into there. So what we're going to do before we actually hit run is just press this diagnostics button, and PixInsight will tell us any warnings or any issues with what it sees for the calibration or the stacking. And all this is doing is telling us that we've got light frames here of various exposures, which is fine. But again, they're all the 180, so I'm not worried about that. And that's going to be, they're going to be calibrated with a master dark, which will be created at 180.3. So again, just shows the accuracy of PixInsight, but all I'm looking at is that everything says 180. So I know that I haven't loaded some 10-second exposure or duration frames in with the 180 frames, which obviously, you know, I want to know about that, and I would have to remove the 10-second ones and add the correct duration ones, the correct 180-second duration files. Okay, so let's just press run. We get the same warning, and this is just a warning. You can read through this if you want, but again, nothing of an issue or nothing to be worried about. We'll just press continue. And PixInsight will now go through and do its thing against our set of frames that we've just loaded. Okay, that took about 15-20 minutes, but I sped the video up. And at the end of it, we get a report just confirming of the different frames, the different light frames, etc., that were used, which was automatically picked for the best reference frame and what our output image was. Okay, so I'm going to click OK on that. We return back to the script. And now I'm going to focus on the 120-second exposure set of frames. So to do that, all we do is with the light selected, press clear, add lights again, and this time go back to our lights, 120 seconds, lights, select them all, okay, they are loaded in, and then I've got, remember, a set of darks that are the correct duration. So we also want to clear these out and load the corresponding set of darks for 120 seconds. But what we have to do here is also, the bold of the star indicates that this file will be used as the master dark. However, we don't want that, because we want a new set of darks to be created based on the 120-second duration as well. So I just untick use master dark. However, for the bias and the flats, you can see the first time round with 180 seconds has created us a master bias frame, and it has also created us a master flat frame. So I'm just going to keep these two ticked, use master flat and use master bias. And this should speed up the second iteration quite considerably. So hit the diagnostics button. Again, just the warning that, you know, there's some slight offsets here from 120 seconds, nothing major, just a quick check through. Click on the run button, we get the same warning, same information warning, and away we go with the 120 seconds. So I'll let this go through and I'll speed up the video as well. And there's the smart report for the 120 seconds. So I'm going to repeat this for our third set of lights, which is going to be based on 60 seconds. So again, clear these out. Find the 60-second folder. Add the lights. Clear out the darks. Add the darks again for the 60 seconds. Untick, use master dark, and we're going to use the master bias and master flat again, so we haven't changed them. Check the diagnostics, which is fine, and then run the process again. Okay, so we're finished stacking all of our 5 different exposure times. And if we look into the output folder, there is a master folder, and we can see there the master light. So 10, 30, 60, 120, and 180 in my case. These are the output files that we'll be opening up in PixInsight and taking a further look at next. Uploaded our 5 images into PixInsight after they've been stacked with our light and calibration frames for each exposure, each duration. And normally we'll just continue processing per usual. However, because we've got 5 images, we need to use the Hdr tool to make a composite of these 5 images. However, before we can do that, we need to align each image against each other because of probably subtle differences that, again, when you PixInsight and calculate, and if we were to place all 5 images on top of each other, I'm sure they wouldn't align directly. So to help us do this, we use a process called star alignment. And just before I get into star alignment, all I've done on these five images is ran the stretch tool or stretch option against them, just so we can see what we're working with. So anyway, these 5 here, all we need to do in star alignment is choose our reference image, which in this case is going to be the view, and I'm going to use the 180 second 180 as our reference. So click OK on that. And then further down, we just add the views of the other 4 images. Click OK, and then we click the circle and let PixInsight do its things. This is basically going to create a new image or new 4 images with an offset that would place them directly on top of the first image or the 180-second image. Okay, so we can close star alignment, and it's created us 1, 2, 3, 4 new images, which is the replacement images with the adjustment based on the 120 or the primary view. So we can close these ones down. We don't close the 180 because that's what we will be using moving forwards. And if I just cascade or fit the images, no, actually tile the windows, and then let's run a stretch on them again, just to see what we've got. And then we should be able to, as an example, if I take this 10-second and just move it over. I'm not sure how well on the video this comes through, but that should be a very, very precise overlay from one image to the other. So basically I'm just showing here that the 10-second image can nicely overlay on the 180 image. And the point of this is if we hadn't aligned the stars first, or hadn't aligned each of the images when we place them on top of each other, they would not be aligned nicely. So I'm going to use Hdr Composition to allow us to integrate these 5 images into a single HDR or high dynamic range composite image. And to do this, we'll first have to save these 5 images out as files, because the process, the Hdr composition process, doesn't allow us to input views. It has to be specific files. I'm just going to save these files out. So file, save as, and then I'm just going to save them into our master. Okay, so let's just call this 120S. Save this at the highest format possible. Okay, close that image now, or close that file out. File, save as, and this one is our 60 second. Save highest format. Okay. Close that out and just repeat that for each of these files. And then we're going to launch the Hdr Composition Tool. And as I said before, this is looking for files as opposed to views. So I'm just going to add all of our 5 files in there. And what I'm going to do here is I'm going to sort them by the exposure length. So that's why I put the exposure length at the start, so we can easily see them. So 180, 120, move the 60 second up and move the 30 second up. Now, the settings here is automatic exposure evaluation. Now, when this is checked, PixInsight through the composition tool or process will attempt to read the exposure length of each image, whereas I'm happy enough to, because I've only got a small number of images, to uncheck that, and Hdr Composition Tool will use the ordering that I've placed these images in. So it knows that the first file is the longest, and going down to the last file is the shortest with regards to exposure time, regardless of whatever I've named them. Okay, so let's, I've got a feeling that something will not go quite right here, but I'm just going to run them as is, and then I'll explain why things go a little bit, well, not wrong, but PixInsight gives us a warning. So let's run this, and PixInsight does its thing. Okay, so if I just show the console there, it's managed to do image 1, image 2, image 3 fine, as in bringing those together. However, once it's got to image 4, which is our 30-second exposure, PixInsight has told us that it can't integrate any further images. Now, the reason for this is PixInsight has calculated, or Hdr Composition has calculated, that in combining or integrating the 30-second image onto the first 3, basically there's no, dynamic differences, so it would be pointless. So PixInsight or Hdr Composition stops at that point. That's what this cannot integrate further aborting process is warning us about. However, to try and improve the core further later down the workflow, one of the reasons that we take shorter exposures is because we want to use those shorter exposures which have not got the overexposed core. We want to use those to try and give us some detail within the core. So how do we tell or force PixInsight to use those 30-second and 10-second frames? So I'm just going to close all that down. And what I want to adjust here is this binarizing threshold slider. And this basically allows us to control the checking, or reduces the threshold that Hdr composition must see from one image to the next image to decide that it should be integrated together. So I'm going to drop that right down to 0.3 and run this again. And hopefully this time through, we will at least manage to integrate the first 4 of the 5 images. So I ran that one more time through with all the 5 different durations, and it was still complaining that the difference between 60 seconds down to 30 seconds was not enough for us to be able to integrate or create a composition for them. So what I've done here is I really do want to use this 10-second file because I believe that's where the detail of the core will come out later. So I've removed the 30 seconds exposure image. So I suppose, there's a difference between 180 to 120 and 120 to 60, which is, obviously a difference of 60 per each file. But when we get from 60 to 30 to 10, there's not that much difference in the exposures. So by pulling out 30, hopefully PixInsight this time around, we'll see that there is a big enough difference in the detail, and it will allow us to add that 10-second exposure file into the composition. I'm also going to uncheck the masks because I don't want the mask, I just want the actual final HDR image. So all that being said and done, let's ask PixInsight to try and do its thing again. Okay, so it's worked that time round. It's created our HDR composition of the 4 images, and I'm just going to auto stretch that image to see what we've got. And we can close HDR composition because we are finished with that. And I'm just going to save this file out just in case we need to go back to it later. So I'm just going to call it as it is HDR. So we've got reference to the process that will last save this as. Okay, so from here on in, we just apply more or less the same workflow that I used for the Andromeda Galaxy video. And let's see how things go from there. Okay, so I'm going to step through the workflow, and to begin with, I'm going to rotate the image 180 degrees. So again, per usual, there's no up in space. People rotate images different ways, different orientations for the personal preference. I'm now going to next run the dynamic crop and cut out any of the stacking artifacts around the edge. So let's just use that. Try and cut off the edges, but make sure I'm not hanging over or halving any stars. So let's just move that in a little bit. I'm going to try and keep that large one there. And we'll just drop down this a little bit as well. So basically, we're just framing the image here for what we want to use going forwards. That looks good. So just apply that crop. Resize the window. And this is what we're going to be working with moving forwards. Okay, so the first thing I want to do is use the DBE, or the Dynamic Background Extraction tool. And to use this, we launch it, click on the actual image itself, and this enables the parameters within the tool. So the DBE, this helps us remove any light pollution or gradients, and also gives a more equal background color across the image. As you can see here at the minute, we're quite dark on the left-hand side, but we are a lighter gradient on the right-hand side here. And the DBE, or Dynamic Background Extraction tool, will help us alleviate those differences and give us a good solid background. So I'm just going to adjust the tolerance, and I'm also going to change the radius, and I'm just going to change this color sample to yellow, which you'll see in a minute helps us see what we're doing. And then I'm going to generate the sample areas. So if you want to see a bit more specifics on why I'm setting those values, please take a look at my Andromeda video. Otherwise, I might do a video in the future with a deep dive onto this DBE process specifically. Okay, so we now go through each of the samples, just moving on to the next sample. If we see a black area in the middle, this is more likely to be a star. We don't want to sample that star, so we'll just click and drag the sample to an area where it's more white as opposed to any black circles. So continuing on, there's another black circle, which is a star. I'm just going to move this out. So the reason why I changed this to yellow is now we can easily see the sample areas that we'll be moving through. There's a double star. Let's move that out. So we just want to subtly move the sample rather than drastically moving it to a different area. And that way, when we run the process in a minute, we'll get a nice balanced calculation across the image. Okay, so I'm just going to continue going through all 68 of these samples. Okay, so let's run the DBE, but actually we need to change the correction to subtraction. So what that does is the background model that will be created in a second is actually subtracted or removed from the original file. So let's run the extraction now. And if we run, there's our background. So if we run a stretch on there, we can see the subtraction or the background that will be removed from the original image. So it's light on the right-hand side and dark on the left, which matches nicely to what we'd seen originally here. So we know we've got a good sample. And this image here, the Hdr DBE, is our image after this background has been subtracted. So we can close the original file. Sorry, I need to close the DBE process itself, then we can close the original file, and we can also close the background. We do not need that any further. So the next thing we're going to do is we're going to do the color calibration using photometric color calibration. And the calibration ways within PixInsight, there's multiple methods. And what this does is it basically neutralizes the background, neutralizes the image, but in this particular way, based on a catalog of, I guess, known areas or ascension and declination parameters that we're going to add in here, basically the approximate coordinates of what we are looking at. So options here, I've filled in through searching for the coordinates. I've typed in M42, clicked search, and that populates the approximate coordinates for us of the object of the image. I've entered the observation date of when I took this image. I've entered the focal length and the pixel size of my camera. And then all we're going to do here is we'll leave everything else as automatic, and we just apply this to run the color calibration. PixInsight will download a catalog if it's not already downloaded. So that'll take a few minutes, and then basically just doing plate solving to make sure that the color calibration is correct, and then it'll actually, well, sorry, the coordinates that we input through the observation date and looking up the object are correct, and then based on that it will apply the correct color coordination for us, color calibration for us, sorry. However, color calibration's been applied, and we can just do an undo and a redo just to see the difference there. It's gone from this like green haze to a much more color calibrated set of kind of rose or red and blues and whites, which is looking nice. Okay, so we can finish with the calibration there. And the next thing we're going to run is a tool called Scnr, which removes the green hue that you see on the image. So I'm just going to apply that. That'll remove the green hue. And again, we can just do an undo and redo to see the difference there. So quite green on the black in the background, but when we've applied the Scnr, it's removed that green and we've got more of a black background, which is good. Okay, so we're going to be using masks quite a bit as we go through, and what we want to do here is set the RGB working space, which is what the Luminance masks are based upon. So originally when you come into here, you can see that any Luminance masks which are based on the RGB working space have kind of got a different ratio between RG and B. However, I want all my masks to take into account the RGB channels equally. So I put the ratios all the way up to 1, and then we'll just click apply global to that. Nothing visually changes at the minute. It just means that our masks going forwards will use equal RGB settings or ratios from the image when we create the mask. So we're going to start off with noise reduction on the background, and to begin with this, we're going to create a Luminance mask which will mask the nebula itself and only apply any noise reduction to the background. So therefore we're using the mask for protection. So I've created a Luminance mask there. However, to make sure that we're only focusing on the background, I'm going to use the Histogram Transformation and the screen transfer function. So I'm just going to reset both of these processes. And with the mask highlighted, I'm going to click on the nuke button or the auto stretch button. And then I'm going to drag this auto stretch into the histogram. And then we are going to see a preview of that. Now, the reason why it's white is because we've stretched once using the transfer function and then stretched a second time on the histogram, and the preview is showing us that twice. So we want to remove one of those stretches so we're not double stretched. What I'm going to do here is to help with the mask kind of not be as subtle in between of masking the foreground and the background. I'm going to clip the shadows, and also I'm going to move, if I just find the slider here, we're just going to see if we take that to the right, the darker and darker it gets. But that's a bit too dark. We want to kind of find the point at where the background becomes a solid black without removing too much of the nebula. Okay, so that looks good enough for a mask at the minute. I'm going to close the preview and then apply those changes by clicking and dragging the triangle into the Luminance mask that was created before. Okay, so we can reduce the histogram and reduce the screen transfer function. And we'll want to apply this mask to our main image, which is just click and drag onto the side. And there is our mask applied. So red is what is being protected. However, the red on the background is being protected. We don't want that in this case. So we invert the mask. And we can now see that the background is black again, and the nebula is red. So it will be the nebula that will be protected in this round of noise reduction. I'm going to remove show mask. So the mask is still applied as indicated by the brown tab on the side. However, we're back to being able to see what's going on with our image. So the actual noise reduction is done through multi-scale linear transform. And I've set these values up already for 1, 2, 3, 4 layers. This is done by simply clicking on noise reduction and then for each layer filling in the 4, 0.5 and 3. So this just basically is how strong we want the noise reduction to be against each layer, with the first layer being the small details and the, well, not the small details, but being the small areas, and layer 4 being the larger structures, which we don't really want to touch. So again, I might do a deep dive video on this process specifically, or you can go and watch the Andromeda Galaxy video that I did before this, which talks more about this particular process. Okay, so with those parameters filled in, I'm just going to, well, actually what I'll do is I'll create you a preview just so you can see what's going on here. And we will apply this noise reduction to the preview window. Okay, so that there is a before the noise reduction was applied, and that is after the noise reduction is applied, so much more smoother. And I'm happy with that. So I'm going to just delete this preview and apply the noise reduction to the entire image. So remember, the mask is still applied here. So it is the background that we are only applying the noise reduction to. Everything else, the nebula is protected at this stage. Okay, so with the noise reduction applied to the background, I'm going to remove the mask. The tab is not orange anymore, so we can see that there is no mask applied. And at this stage, I'm going to do a non-linear stretch. So this basically, again, using the screen transfer function and the histogram transformation, reset both of these. And I'm going to click on the stretch button. And then I'm going to zoom in on the adjustments that have been made. So the reason that I do it at this level is I'm trusting PixInsight that it's managed to do a correct or a good enough auto stretch. I'm just going to slightly adjust this down to darken the background a little bit, not too much, because if we go too far, it looks, I guess, too dark, too over, I guess, processed. So we just need to find that balance. Okay, let's just play around with this just a little bit. And then I'm going to apply that histogram, or that change, the screen transfer function change, into the histogram. And then I'm going to actually apply the changes into the image itself. So what we're doing here is basically we're auto stretching it, and then we apply that auto stretch to the image so that it's permanent, and that takes us into the non-linear side of things. So click and drag into there. We are double stretched, of course. Just remove the first stretch, I suppose, that were launched via the screen transfer function. And now we are good to move forward. Okay, so we don't need to use the auto stretch function any further because that stretch is now permanently within our image. Okay, so now that we're in a non-linear mode, another noise reduction process we're going to apply is ACDNR, which is adaptive contrast driven noise reduction. And this is very good for noise reduction, especially within a linear state, which is what we are currently in. So let's create a preview for this. So let's see whether this comes out on the video. So again, I've set up standard deviation of 2 and amount of 0.75. And if you want further details on this, look out for a future video, or you can have a look at my Andromeda Galaxy video. Apply the filter to the preview, and let's see if we can visually see anything. So previously there you can see a lot of pixelation, a lot of noise in the background, and then once that's been applied, much more smoother. So we've done a noise reduction while we were in a linear state, and then a noise reduction while we were in the non-linear state. Okay, so I'm happy with that. So I'm going to delete the preview and then apply that to our entire image. Okay, so that continues to look good. And we'll now minimize the ACDNR noise reduction. And at this stage, we can do a subtle stretch on that again. So let's load up our histogram transformation. I've selected the HDR DBE, which is the image view, just so we can see the histogram at the top here. And then I'm just going to drag this slightly to the right. Actually, we'll reset that and we'll do it on a preview just to be safe, keeping the habit of using previews where possible. Okay, so apply that. Again, we don't want to go too far and make everything too dark. This is just a case of using the eye very subtly, looking at the background, looking at the nebula. And especially, you know, these dust areas, the orange areas around are coming out nicely. We don't want to lose too much of those. Okay, so I'm just going to keep with that preview. Close that preview and keep with that subtle stretch. So close the preview and then click and drag the histogram onto the main image, and that applies it for us. So now that we've got the noise reduced in the background, we're going to start focusing on the nebula itself. Just a quick check to make sure that we've got all masks removed, which we have. And this time we're going to make a mask using the range selection process. So we're going to go into preview here. And again, what we're going to do here is we want to create a mask around the nebula itself. And then we're going to make sure that the background is protected, but work on the nebula. And range selection for this, fuzziness, smoothness, you'll want to change. And then you can press the preview button. And want to make sure by using this lower limit, if we're too low here, we're not really creating a mask around the nebula. And if we're too high, we're just focusing on the very core itself, which is not what we want to do yet. So just going to bring the lowest limit up to about 0.35. And then again, not sure if it comes through on the video, but you can just kind of feel or move the mask around to see where it'll sit. So that's a little bit too large. I'm just going to reduce it again slightly. Okay, so happy with that. So remove the preview and then click and drag the mask into the image. or to create the mask. The mask is now created, and again, click and drag the mask itself to the side, and that will apply the image, apply the mask to the image. We can view by going show mask, and now we can see the red is protected, so the background is protected, and it'll be the nebula that we are focusing on this time around. So let's minimize range selection for the minute. Back to a new tool called local histogram equalization, and what this allows to do is bring a bit more contrast into the image, or strengthens it up. So this will only be applied to the nebula itself. We don't want to be changing or adjusting anything on the background. We can do a preview of this. Now remember, we're just looking at the nebula here. And if it's too high, what we're looking at here is the amount. Basically, everything looks a little bit too false. But if we drop it down too low, obviously no amount is really applied. So let's try and go a little bit in between here. Again, too high, it looks a little bit false. So let's a little bit higher, I think. Okay, so what we're looking for around here in the nebula is kind of like what I call the veins of the nebula is starting to come out. Let's just try a little bit higher, see if we go too far on things. Okay, so we'll leave that there, and we're going to close the preview and now apply those changes to the image itself. Okay, and we're going to repeat that process, but we're going to focus more now in the center of the core. So remove mask. We're going to make a new mask. So back to range selection, preview. However, because we just want the core area, we're going to really push this low limit high. So we'll get into the core itself a little bit further. Okay, so I'm just like clicking and moving the mask just so I can see what's picking up. Close that preview and then apply the range selection. That'll create the mask for us. And then we apply the mask to the image. Okay, there. So again, red is protected, the background is protected. I'm just going to unshow the mask. And we'll go back into local histogram equalization, preview. And again, using this amount, what we're doing here is looking in this very, very central area. And we kind of just want to make sure that everything is smooth or merges naturally from the core going outwards into the nebula. So if it's too low, you know, we're going from a white state straight into the nebula. If it's too high, it looks a little bit too dark, a little bit too false. So we need to find that balance of merging the core into the nebula area itself. Okay, so I think that looks quite good, I think, from eye. Okay, and later on we'll focus again more specifically on the core in the next stage. So, you know, at this point here, I'm still expecting a white core, but we'll not worry about that on this particular step. Okay, so happy with the preview. Going to close the preview and then apply the changes into the image. And then we can now minimize the local histogram, and we're done with that. And we can now remove the masks. Okay, so we're going to use a tool called Hdr Multi-Scale Transform. And what this does is it allows us to bring out the details from areas that are too bright, such as the core, and it brings out the details behind that to the surface. So it's quite a powerful tool because it shows that the data is in there from the 10-second exposure images that we took. And to do this, basically what we're going to be doing here is changing the number of layers. But like a lot of things in PixInsight, it's trying to find out, a value of 6 is better than the value of 7 or a value of 8, etc. So to help us decide and to speed up the processing as well, I'm going to create a preview around the core. And a nice little tip here is we've got preview 1, which we can see there. But if we click and drag the preview tab down, it quickly creates us as many previews as we want of the same area. And I'm just going to make sure that we are zoomed out to the right level on all of them, or the same across all of them. And the first preview I'm just going to leave as is. Well, no, actually, first preview we'll leave as is. The next preview down, we will apply the 6-layer setting. And then the next layer down, we will apply a 7-layer setting. Oh, that's, yeah. And for the last one, we'll try an 8-layer setting. Okay, so no changes. That's the same as our original one, just zoomed in. 6 layers, 7 layers, 8 layers. So again, we're just using our eye to see which one visually feels the best or looks the best. And I think I'm going to go with this preview here. Okay, so this was our 7-layer one. Okay, so we can close the previews. I want to go down to 7, close all the previews, and then we apply the 7-layer to the full image. Okay, and if we zoom in there, we can see that the core now has brought its detail out. And if we do a before and after, you can see that the blown core has been removed and we've managed to bring the detail through into the image, which looks much better. So we could go and create a star mask, but I don't think this image really needs it. Yes, we've got some large stars, but I quite like them, and the background is not star intense. So I'm not going to bother reducing those stars at all. So the final thing that we need to do is just some final work with Curve's transformation process, which allows us to bring out a bit of the saturation and a little bit more color into the image. So per usual, we select preview, and I'm just going to make a slight curve here. So what we're doing here is setting the contrast or creating a little bit more difference between the foreground or the structure of the nebula in the background. Not a little bit too much because we don't want to create a false sense of being too dark in the background. And then this will allow us to bring out the saturation easier within the nebula itself. So happy with that. So I'm just going to apply that stretch or curve adjustment into the image itself. Back to preview. And now we're going to bring the saturation into the image. Okay, so this is definitely where it's artistic license. Too much and it looks too blue, too purple, too low and black and white and grey. So I think about So I want to keep a nice balance between the red in the nebula and the blues. Okay, so happy with that at the minute. Move on to the C component channel, and we'll do the same with that, but not as much. So again, too much. You can see they're really pushing it. It's just moving this gently to get a feel for the color adjustments. And then the last one we can do is the Hue Curve. So again, just to get a feel what it does, that's into the oranges, into the yellows, and that'll blow it out. So just need a nice somewhere in the middle. Just a subtle change on this one I found. That's too much purple, which we don't want when trying to stay with those blues and reds. Okay, so I think that looks good. We've got blue around the nebular area, and we can kind of see the orangey reds of the dust around it. And I think the nebula is looking good. And also the stars, different colors, some nice blues and whites with a hint of reds and oranges in there. Okay, so let's close the preview, apply those changes in, and that gives us a little bit more color in our image. And we've got no masks applied, so I think that is what I'd call done. So thank you very much for watching this video. Please subscribe if you'd like to be notified of future ones. And also if you've got any constructive feedback, any constructive ideas, or you would just like to say that you enjoyed watching this video, then please feel free to leave any comments below this video itself. So until next time, I've enjoyed working on this image. I've enjoyed expanding on my workflow in PixInsight and learning some new processes as well. So thank you.